Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to help you understand how to graph parabolas. And first of all, chat about this. Parabolas come in two types. You have parabolas that open vertically, either up or down. So when they open vertically, this is the kind of general form for them. Y equals ax squared plus bx plus c. For an example, maybe, whoops, let's get that pen rolling here. For example, y equals 3x squared minus 2x plus 5. There's an example of a parabola that opens vertically. Now, you can tell whether it opens up or down by the number in front of the x squared term. If a is positive or greater than 0, then the parabola opens up, something like this. If a is negative, right, or if a is less than 0, then the parabola opens down. Right. Parabolas can also open left or right. When they are of this form, x equals ay squared plus by plus c, then they're going to open horizontally. You can tell which way they open, right or left, by looking at the a value again in front of the y squareds. If this value here is positive, greater than 0, then the parabola will open to the right, something like this. If this value is negative, then it will open to the left. So as a quick example here, x equals maybe negative 2y squared plus 3y minus 1. I'm just making that up off the top of my head. Taking a look at this, our value for a is negative 2. This parabola opens to the left like so. Now, to graph them, what you want to do is you want to start by identifying whether it opens left or right, and then by finding the vertex. Now, I've got another video that describes why this works, but in either case, you find the vertex by taking a look at this term, minus b over 2a. In this case, over on the left, this will tell you the x-coordinate of the vertex. In this example, it would be minus a minus 2 over 2 times 3. You then take that numerical value and you sub it back into the equation to get the y value. Over on the right, same deal. You look at the expression minus b over 2a, except here what this gives you is the y-coordinate of the vertex. You would then take that numerical value, sub it back into the equation to get the x value. Once you have the vertex and you know which way it opens, a couple more points is typically enough to get a pretty good sketch of the graph. So I'm going to go ahead and look at some examples of that. All right, so we're going to go ahead and sketch a graph of this guy, y equals x squared plus 2x plus 3. Now, first we want to recognize that this thing opens up because it's in the form y equals here. The a is 1, the b is 2, the c is 3. Oh, and I should say it opens up because the number in front of the x squared term is positive. First thing we're going to do is get the x-coordinate of the vertex. And that's going to be minus b, that'd be minus 2 over 2 times 1. And we get negative 1 out of that. To get the y-coordinate of the vertex, we'll take this value and we'll sub it back in here and here. So the y-coordinate of the vertex is going to be negative 1 squared plus 2 times negative 1 plus 3. Now, this minus sign is also being squared, so you have to have these parentheses here if you write this out. Let's get a value here. Let's see, 1 minus 2 is minus 1, plus 3 is 2, I believe. I'm going to go ahead and double check that again. This is a 1, and that's minus 2 plus 3. Yep. So the vertex, we know, is at the point negative 1, 2. So we go to our graph, 1 to the left, 2 up. There's our vertex. Now, we know it opens up. It's going to look something like this. A little more detail would be kind of nice. Here'd be a real nice easy point to get. Let's go ahead and get the y-intercept. We can do that by looking at where x is equal to 0. Y would equal 0 squared plus 2 times 0 plus 3, which is 3. So we know it goes through the point 0, 3. So 0, 1, 2, 3. Now, parabolas are symmetric. This parabola is going to be symmetric about this line, x equals minus 1. go ahead and do this, put a dashed line here. They're always symmetric about the vertex. So that means if I go right one, up one, there's a point. Well, that means also if I go left one, up one, there's another point. So you can check it. I'll leave this to an exercise to the reader here, but if you put x equals -2 into this and run it, you should get 3 out. I'm going to go ahead and get maybe one more point here. Let's put x equals 1 in. And then we'll get, we'll get a point over here somewhere. And then y is going to equal 1 squared plus 2 times 1 plus 3, which is equal to 1 plus 2 plus 3, which is 6. So we know that if x is 1, y is 6. So 1, and then 1, 2, 3, 4, 5, 6. There we go. Now, these are symmetric. So if I go 1, 2 over, and then 1, 2, 3, 4 up, using symmetry, if we go 2 over, 4 up, there should be another point. And you can go ahead and try this. If you put in, let's see, 1, 2, 3, -3 into this function, 6 should come out. That's enough here. We'll go ahead and just sketch it now. So this thing's looking something like this. And then like so. That's good enough. Now, anytime you're sketching parabolas or really any function, you really should identify domain and range. So let's do that. So the domain of this function is, we take a look at the function, you can put anything you want into that, you're going to get a value out. So it's all real numbers. Range. Now, you notice there are no y values down here. The smallest y value we see is 2, and they are all larger than that, so the range, we'll just say, is y is greater than or equal to 2. All right? So there's an example of graphing a parabola here. Let's go ahead and take a look at another one. Oh, one more thing. So let's talk about this axis of symmetry here. The equation for that axis of symmetry is x equals -1. Anytime these parabolas open up or down, the axis of symmetry will be, make a better x there, will be of this form, x equals some number. If they open left or right, kind of like this, the equation of symmetry will be, the line of symmetry will be horizontal, and it will have a form y equals something. So let's take a look at another example here. Now, there's a parabola that's going to open right or left. So first thing you want to do is decide right or left. Now you look at this term, the number in front of it here is a +1, so this thing is going to open something like this. I'll just do a quick little reminder here. We know it's going to open horizontally to the right. The y coordinate of the vertex we can get by -b over 2a. Let's go ahead and do that. So that's going to be -b, which is -1, over 2 times a. A is 1. So we get 1/2. Now we're going to take that value, sub it back into this equation here to get the x coordinate of the vertex. Right, so 1/2 squared minus 1/2 minus 6. So that's going to give us, let's see, 1/4 minus 1/2 minus 6. Oh, and let's common denominator this. That'd be a 4. So 1 over 4 minus 2 over 4 minus, if we write this with a denominator of 4, that'd be 24 over 4. So what do we got here? -1 minus 25/4. Let me just double check and make sure this is good before I move on here. So 1/4, 1/2, 1/6, 1 over 4, 2 over 4, 24 over 4. Okay, and now we can start thinking about what our graph looks like. Just give me a moment here. All right, so x coordinate of our vertex, -25/4. In decimal form, that's -6.25. So if we go 6.25 to the left, 1, 2, 3, 4, 5, 6. 0.25 is a quarter there. and then plus 1/2. That's about right there. Now, we know that this thing is going to open to the right, so it's going to look, something like this. A real easy point to get would be where it crosses the x-axis here. So y would be 0 at that point. And you notice if you put zeros here and here, you get -6 out. So we know it goes through this point right here. That's not too much help. I'll go ahead and put that on there. And also, this thing is symmetrical, so that point will be on the graph. Where this graph crosses the y-axis would be a very good point to get. We can get that by setting x equal to 0 and solving this for y. And looks like this thing's probably going to factor. Let's try y minus 3, y plus 2. I think that works. Inner, outer term. Yep. Okay. So this yields a solution of y equals 3, and this one yields a solution of y equals -2. Weird looking 3 there. There we go. 3. All right, so we know that it goes through the point 0, 3. 1, 2, 3. We know that it goes through the point 0, -2. And I think we're good. Now, I'm just going to go ahead and sketch this, but it wouldn't be a bad idea to maybe get a point over here, maybe x equals 4 or something, solve for y. You'll notice it's quadratic, you'll get 2 of them, but I'm going to go ahead and just sketch, use what I have here. We know it looks like this. I'll just kind of do like so. Supposed to go through that point. Oops, actually right there. Maybe I can draw that a little better. Oh no, not what I wanted to do. See if that will go. Nope, not going to do what I want. I don't like using Word for this. All right, we'll just leave it. That point's supposed to go. I guess that's going to let me delete that. There we go. All right. Oops, now I got to get my pen back. Word is a little bit of a pain for this. All right, let's sketch this here, and it goes through 0, -2. There we go, and off to the right. Good enough. All right, so axis of symmetry. Whoops. All right, that goes through the vertex. This graph is symmetric about this line, and that's the line y equals 1/2. Now, this graph, this is not a function. It does not pass the vertical line test. However, we can at least talk like what values of x can we get this to work. I wouldn't call it a domain. You don't normally attach the word domain to things that are not functions, but this equation will at least give you y values for x greater than or equal to -6.25. And possible y values that will come out of this. Now, it doesn't look like it. The graph might be a little bit misleading, but this is just going to go on forever, up, 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 and same thing here, to the right, down, 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 down. So the y values that will come out of that are really all real numbers. Now, I wouldn't call this a domain and range again because this is not a function. So this video was intended to help you understand how to sketch graphs of parabolas. I hope that it's done that for you. Have a great day.